we're going to generate two different bromination sites. Or sorry, radical sites. We'd end up with one here and one here. From this point, these can each lead to a product. As well, each of these has resonance. Which can lead to products. Oh, forgot the BR in the product. So this could lead to a product here, and then our other one on the other side also has the ability to lead to a product. Which would look like this. Man, that BR is rough. So these would be the four products of this reaction. Technically, you could have some sort of a cis and trans here. I'm not going to make you guys deal with that for this, though. So taking a look at our bottom one, we're going to have probably 6 products. We've got a secondary, a primary, and a secondary center here. Someone asked, are the second and the fourth product the same? They are. So, yes, it's a good point. These two are the same. If you just kind of rotate that around, they'll end up being the same thing. So technically, there's only 3 products for this reaction. I'm not going to mark you down for drawing all 4 of them, but yes, those 2 are the same. Okay. And that'll actually probably make it your major product, just because you're going to get like a 25% ratio of each of these. If you think of it, you got 25%. Randomly. But these two happen to be the same. That's going to equal a total of 50%. And this would technically be your major product from this reaction. All right, so each of these is going to or secondary and primary positions are going to lead to a radical. So each of these radicals should lead to a product. Each of them should have one resonance structure. So you can move our electron, form a double bond. This one should be different because of that methyl group on the side. Gonna start running low on space though. So this will lead to another product. our middle one can shift up that double bond into the methyl group. Nope, that should just be a BR. And then our last one can shift our radical onto that tertiary center. To give us this product here. I think these are all 6 unique products. I don't think any of these are the same, so this one probably won't have a major. There may be one that's slightly more prevalent, but I'm not going to have you guys try to figure that out. So, are there any questions about these reactions? Okay. If not, we're going to take about a, I don't know, let's take a 10-minute break. So we're going to meet back here at 10:10, and then we'll start on doing some synthesis questions that involve all the 3 chapters we're going to talk about. So 8, 9, and 10 combined synthesis reactions. All right, so I'm going to walk through a couple of synthesis problems and kind of talk about some strategies. So let's just take let's do this here. This one looks pretty straightforward, but in actuality, this is going to take a lot of steps to get here. All right, so taking a look at our starting material and our product, we've got this branch point and then 2 carbons, which means that this should fit nicely into here. We only really know one reaction that makes carbon-carbon bonds. So if we want to get an extra carbon in this reaction, we need to get to some sort of alkyne, add in NaNH2, and then something like methyl iodide. So if we wanted to do that for this here, and I'm just going to kind of chunk through this, some different things that we could do in the middle. It would probably be advantageous. I'm going to draw these little backwards arrows. These are called retrosynthesis arrows. Why they chose to make them go backwards, I have no idea. And essentially, you're just like looking for points that make sense within your synthesis. So you know you have to add a carbon, which means you know you have to have some sort of alkyne. It would make the most sense for it to look something like this. So you can add this carbon on and then reduce it. So by using this, this kind of gives us a midway point, something to kind of our goal to move towards. And then from this point, we can go to our product. And this is a good way to approach synthesis problems. Try to figure out if you can move back a couple of reactions, figure out how to get to that, and then figure out how to get from that to your product. So we're going to break this really into 2 synthesis. I'm going to redraw this. Where we're going to have a synthesis where we're making this half and then another one over here. So the nice thing about making alkynes is typically you use the exact same reagents to do them. If we have nothing on our molecule, like we do on the right here, this is just a straight carbon chain. There's only one reaction we can, or actually 2 reactions we can do. So you can either add in Br2 and light or Cl2 and light. Br2 is going to brominate on this tertiary position. We did the math previously, so we know that the Cl is going to brominate or chlorinate on this secondary position. Most likely, looking at where our alkyne is, it would be better to have the Cl than the Br. Realistically, if you added in a small base, we can make a double bond and then get to here with HCl peroxide. Either of these would be acceptable. So having this group on this secondary position is advantageous. We can then eliminate it. We're going to want to use a large base because looking at where our alkyne is, we're going to want to form our double bond in this position. Terbutoxide tends to be our go-to large base. Like so. So now we have a double bond. Going from a double bond to a triple bond, there's going to be one way to do it that is kind of universal. You're going to use it over and over again. So the more you use it, the more you get used to it. And that is going to be adding in Br2. Followed by NaNH2. So that'll do a double elimination. You'll form this alkyne here. So these steps, I'm going to kind of highlight the route, the direct route here. Tend to get a little repetitive. You're going to kind of do these ones over and over again. You'll do some sort of chlorination or bromination, eliminate to form a double bond, and then use this little triple bond pathway to get to your triple bond. And then for a lot of these, we're just going to be doing reagents, a couple of reactions with our triple bond. So we're trying to elongate. We've kind of completed our first half here. We're missing a carbon. So if we add in NaNH2, methyl iodide, we can get the correct number of carbons, and then reducing it down to single bonds with H2 and platinum gets us to our final answer. So this one was a total of 6 steps here, which is pretty reasonable for what you guys should be expecting. There may be 1 or 2 examples from the previous exams that are longer than this. I'm not going to go more than 6 steps on an exam for the summer, so this is a pretty, I would say, straightforward synthesis for you guys. I'm going to give you guys another one. Let's see. Have you guys work through it. And then we'll talk about it together. So let's take a minute and go through. Clear these. I'm going to have you guys go through and try to do this example here on your own. So it's going to follow similar patterns. You need to make a longer chain. So you're going to have to make some sort of an alkyne. And then from there, you're going to do a couple reactions with an alkyne. So I'm going to give you guys till 10:28 to try to do this one. And then we're going to talk through it together. So if you guys have any questions during this time, kind of feel free to reach out and I can kind of help push you on the right direction if you are struggling. All right, so I'm going to kind of break this down backwards and then work through it in the forward direction. So if I think about this, I probably need some sort of alkyne to get here. Should look something like this. We've only got 2 carbons in our starting material. Those are most likely made up of alkyne. So we could break this down to here, this, and then we're roughly going through some sort of a pathway like this here. So let's talk through some of these reactions. First one is going to be getting to this alkyne, and then from there it's kind of straightforward. It's a lot of reactions we've done a lot of times. So again, we're doing a very similar pattern to what we did in the previous one. There's nothing on our molecule to work with, which means we could only do a bromination or a chlorination. There's not any difference between these two. I'm going to throw in Br2 and light. It's going to put a Br on one of these 2 positions. They're symmetrical, doesn't matter which one. From here, we could make a double bond, throwing in any base. So let's just, I don't know, we use the same one, I use the big one. And then going from a double bond to a triple bond, we're going to use the same pattern. So Br2, to dibrominate, NaNH2, gets us to a triple bond. From here, a lot of these reactions are straightforward. So we need to add the left and the right half of our molecule. Let's do the left first. Doesn't matter which one you do in which direction. I'm just picking one. We can add the right half, so there's 2 carbons over there. This gives us our basic skeleton. From here, we just need a trans bond, so throwing in sodium and ammonia. Gets us to our final product. This one might have been a little bit longer. We got 1, 2, 3, 4, 5, 6, 7 steps here. 5 and 6 are kind of rinse and repeat, but still within probably the frame you guys will probably see. Okay, I'm going to give you guys a couple of examples to work through. The first one is going to be a little bit easier. The next 2 are going to be more like this. I'm going to give you guys, I don't know, maybe 12, 13 minutes to try to do them. And then we will talk through them together. We'll see how far we get into them. All right, so let's take some time to work through these. I'll give you guys till about 44, and then we'll walk through them together. Okay, so let's get started on this first one. Taking a look at our product, most likely the double bond comes from the triple bond. I mean, it would be pretty hard to shift it all that much. So we're going to be doing just kind of a direct addition and then reduction to a cis double bond here. We got two different sides of our double bond. So it doesn't matter which one we add first. I'm just going to do the left first because that's easier for me to think about. So throwing in NaNH2. We've got 3 carbons over here. Which means we're going to need 3 carbons and the leaving group. Our right side going to be kind of rinse and repeat. We're going to have 1 carbon, 6-membered ring. Should look something like this here. And now we just need to make a cis double bond instead of a triple bond. So we're going to add an H2 and Lindlar's. Any questions on this problem? Okay, let's move on to the next one. Next one's more complicated. We're starting to do more of the reactions that we've been doing. So we got this 6-membered ring complex. Based on what we know, we're going to need some sort of an alkyne. So I'm going to work a little bit backwards and then try to go forward through this. So we probably need to generate something that looks like this here. Then we could add in our BH3THF, NaOH, and peroxide to generate our final product here. So our goal is to try to generate one of these terminal alkynes. Did I make this a 5-member ring instead of a 6-member ring? No, it doesn't really matter. Okay. So if we try to chlorinate, we're going to run into an issue. Chlorination most likely is going to end up putting us in one of these secondary positions. So we're going to have to brominate and probably shift. So if we add Br2 and light, it's going to go to our tertiary position. I think I did have a 5-member ring on these. Not that it makes that much of a difference. So bromination, it's going to put our Br here. We're going to need to move this in order to make our alkyne. So we got to eliminate it. There's only one beta position, so it doesn't really matter what base you put in. And now we're trying to make our alkyne over here, which means we're probably going to want our Br to form on this less substituted position, not on our more substituted, because that would just going backwards. So if we add an HBr and peroxide, we can get to what looks like a much more manageable position. So this is kind of the pathway that we've been doing. We should kind of know what we're doing from this point. If we add in a large base, we can make a double bond. That is in the spot where a triple bond is going to be. So going from a double bond to a triple bond is the same way. We throw in Br2. Followed by NaNH2. Lastly, as we talked about, getting to our final product, all we have to do is throw in our BH3 in NaOH and peroxide. Okay, any questions on this one? All right, so I'm going to stop here. I'm going to let you guys work on the last one over tonight. We'll start the beginning of the class with that one. And then from there, we'll do some NMR tomorrow, and then that'll be all the material that is going to be covered on exam 1. Yep, I'll draw the last one up in a second. I'll give you guys a couple minutes to write this, and then I can probably delete the first part of it and redraw it over here. So the last one was this here. Little box around it. So I will see you guys tomorrow. Have a good rest of your Thursday.
Do we have recitation today?
Yes. If you're in the 12 o'clock recitation, we have one today. If you're in the 11 o'clock one, it'll be tomorrow.
Okay.
So that means we have the office hour today from 11 to 12, right?
Yes. And then tomorrow from 12 to
Thank
1.
you. Thank you.
You're welcome.